Here we go. So, like I said, we are moving into logarithms. Logarithms is actually one of my favorite things. I guess I could write that a little bit bigger for you guys, in the room. Or is that big enough to see? You guys can see it pretty good? All right. So basically a logarithm, like I said, is just another way of writing exponents. So if I have an exponent, finish writing the word exponent. If I have, say, the exponent bx, b to the x power, can't make an x now, b to the x power equals a, writing it in its logarithmic form would be log base b of a equals x. Now, when I'm doing logarithms, I always think of it in terms of first, middle, last. First, last, middle. Right? I go first, last, middle, and it is how I can remember how to convert between the two. Right? So if I have b of x equals a, b to the x equals a, and I want to write that in logarithmic form, I go log, first is my base, last equals middle, right? This is my first piece, this is my last piece, this is my middle piece, right? I go first, last, then middle. If I'm doing it the opposite, if I have log of b a equals x and I want to convert it, again, I go first, last, middle. I go, well, this is my first, this b, so I'm just going to write it b. Then I'm going to take my last part and it becomes my exponent equals my middle. So just try and remember first, last, middle. And we're going to do that with actual logarithms now instead of just like supplemental, right? These are just formulaic. But if we have, say, for example, and we'll do a lot of examples today, just so you have lots of opportunities to see how it works. If I have log base 3 of 9 equals 2, and I want to convert it to exponential form, I would go first, last, middle. Does that make sense? Let's see, log base 6 of 216 equals 3 would be first, which is 6, last to the third equals the middle, 216, right? Notice that our end is just our exponent, right? We're saying that this raised to this power equals this, right? If I take this number and I raise it to the power of this, it's going to equal that. It's like a circular motion, right? First, last, middle. Let's do one more just so you can see one with a fraction. If I have log base 4 of 1/16 equals -2. It's still going to solve first, last, middle, right? This right here raised to this equals this. Feel the momentum with that? So like I said, none of this is particularly hard. It's just learning the rhythm that goes with it. When we go to convert in the other direction, right? So we were converting log to exponent. Now we're going to convert exponent to log. First, last, middle, still in play, right? If I have 14 squared equals 196, and I need to convert that, I'm going to do the same thing, right? I'm going to start with my log, and I'm going to go first, which is 14, last, which is 196, equals the middle, which is 2. You guys could not look more bored. And nobody's taking notes. Do you guys never take notes?
What if they said no?
Well, I would tell you you'll do a whole lot better in school if you did.
I mean, that is
Yeah.
true. That is true.
There's something in writing it that helps you remember it.
That's true. But there's also a video.
Yeah. But like I said, there's something in the writing it that helps you remember it. There's something about practice. Maybe it's just muscle memory. I was the worst high school student on the planet. Like I was literally kicked out of high school. And when I went to college, I started taking notes in class, and I didn't always understand the notes while I was in class, but I would rewrite them that day, and then I would start to get it because I wasn't a naturally good math student, and I wound up majoring in math. So we've got 3 to the 4th equals 81, right? And so when I go to do my first, last, middle, I've got my log, and I know it's 3 is my first, my last is 81, equals my middle, which is 4. Right? 3 to the 4th power equals 81. It still follows that same procedure, right? 3 to the 4th equals 81. 14 squared equals 196. Do one more. 2 to the -3 equals 1/8. Well, we want to convert that. We're going to get first, which is log base 2. Last is 1/8. Middle, -3. 2 to the -3 equals 1/8. You guys doing okay there online? Sometimes you'll see a logarithm that doesn't have a base. And if a logarithm doesn't have a base, it's considered base 10. We call it the common log. That got small. That's what you got full size. That's why you guys was looking all small up there. I wasn't at 100% over here. Not the man log, but the common log. The common log is a logarithm of base 10. This is the only log. The common log and the natural logs are really the only logs you can use on a calculator. And so we tend to convert everything to common log if we want to solve it, right? So it's basically log base 10 of x equals log of x. We just don't write the base, right? You can see it with the base, but if you see something without a base, you automatically know that it is log base 10. And we need it for evaluating logarithms. Whenever you're asked to do anything in math that says evaluate, they're looking for a numerical answer, a solution to the problem, right? So if I'm instructed to evaluate and I have a problem like log base 749, right? If I'm going to evaluate this problem, what I have to do is I'm going to have to, in this case, put it into exponential form, right? And then figure out what my exponent is. So I am going to rewrite this. I'm going to write it as in exponential form. So I've got 7 to the x, because we don't know what it equals yet, equals 49, right? And I can look at that right off the bat and go, oh, I know that x equals 2, right? Because 7 squared equals 49. But what you're looking for is the x, right? It didn't give us one in this problem. It just gave us evaluate log 7 of 49. And I had to go, okay, well, I know it equals something. And my something is the unknown. So I'm going to make that an x. So if I have, for another example, log base 327, I could say it equals x. I don't know what it equals, right? But I could write this as 3 to the x equals 27, and I can see it. I know my powers, and I can go, okay, well, x just equals 3. But there's going to be situations where you're not going to be able to intuitively know how to do that. And so you need to be able to write these in a base 10 form. And to do that, we need what we call the change of base formula. The change of base formula is another thing that is super simple once you know how to do it. Right? Change of base formula puts everything in base 10 for us. So if I have log base b of a, I can write it as log of a over log of b, right? And that gave me base 10. Notice these don't have any bases, so they're automatically base 10, and it allows us to plug them into a calculator and get a solution for the problems. So if I have, say, log base 16 of 64, and I need to evaluate, right? I have to come up with a numerical solution, evaluate. I need a number solution to this problem. I'm going to go, okay, well, I need the change of base because 16, 64, I don't know how to make those, like 16 raised to something doesn't become 64, no solid number, right? 16 squared does not equal 64, it equals like 200 and something. So I can rewrite this as log of 64 over log of 16, right? It is a common log. Now we can plug it into a calculator and get a numerical solution. But there's no way to just plug in log base 16 of 64 into a calculator. And I don't know how much experience you guys have with scientific calculators, but there is always a button that says log. And so you can just plug this in now. You can hit that button log. You can see it right there, right under the second. And if I plug that in, right, it gives me log with a parentheses. And then I could put in above it, I could put in 64 and the parentheses. And then I could hit divided by and hit log again. And I get another parentheses. And I could put in 16 and end the parentheses. And then it's going to give me 3.45. And that would be my solution. When I'm evaluating, what I'm looking for is a solution. And that would be 3.45. Right? It goes on, but we can round things. So again, if I have log base 254 and I have to evaluate it, I'm going to put it in the common log form, right? I'm going to use my change of base and I'm going to write it as log of 54 over log of 2. What does that equal? It equals 5.7549, or we could just call it log, or we could call it 5.8, right? Whatever it tells you to round to. That's all you have to do for your homework. I believe that is as far as this lesson will take you, right? Your homework has 21 problems on it, but they all go this fast. If you look at this, we probably did 15 problems while I was discussing everything, right? And they all went super fast. None of them are hard. They don't require a ton of math. The hardest part is where you have to start using the change of base to evaluate. I will tell you right now that until you get to number 16 on your homework, 16 through 21, you'll have to use the change of base. It doesn't tell you that, but I'm telling you that, right? The others you can look at pretty well and tell what you have to do, right? You can go, okay, I just need to raise it, rewrite it, and you can see what X equals. Because they're easy. They're all perfect squares or perfect cubes. So you can kind of figure them out if you write them in that exponential form from the logarithmic. But numbers 16 through 21, you can't look at it and know what it is. You have to write it in the change of base form and then plug it into a calculator to get your solution. Any questions about any of that? We went fairly quick with it. Alfonso, Joey, how do you guys feel? Yeah? Bailey, Evan, who else I got there? Liliana? You're good? You feel like you got it? The worksheet is already posted in PowerSchool, so you guys have access to that now. I recommend you start working on it. The sooner you start working on it, the better it's going to stick, and you are less likely to have to go back and watch the video if you do it that way. You guys are free to go work on it. You guys, if you want me to print one up for you, I can do that for you too. What, are you just going to sit here and do nothing?
Yeah.
No.
That sounds pretty fun.
No. I'm not wearing a mask for you guys to do nothing. Take it easy, Bailey. I'll see you Thursday. We should at least play a game or something. What's that?
Math style hangman.
Math style hangman?
That sounds very good.
There is a game I saw on TikTok, and I got to remember how it goes. It was a math game on TikTok. I might actually even send it to myself. So let me see.
Yeah,
Because I do stupid stuff like that. Send myself
for whatever reason, you mentioning TikTok made me reminded me of like this stupid. I don't even know if it was a fad, but like this one tattoo that circulated for a while of like for some reason it was called a Gen Z tattoo. You get it on like your neck or something. And in reality, the symbol was like the insignia of like the Fourth SS Polizei Division.
What?
Yeah, so a bunch of people who didn't know got like a literal insignia of an SS division like plastered on their neck.
People are so stupid. How would you? Why would anyone tattoo anything on them if they didn't know what it meant? Or the ones where they get them misspelled. Like, how do you not check the spelling before you let them tattoo you?
People are stupid. My dad's got a lot of weird tattoos from his from when he was like way younger. There's
I guess I gotta look at. All my online people have left the line.
was it? Oh, I know. I know it's close.
I have so many recipes on here. That's what I usually send myself.
The fourth SS Polizei Panzergrenadier Division. Like, because it seemed like a very innocuous symbol, because it was just a Z, like a little cross through it. It was this one.
Yeah, that's how I write my Z's. I didn't know that was a Nazi symbol.
It's.
I just do it so you could distinguish my Z's from my number 2.
I mean, that makes sense. I wonder why it's like that.
I guess I didn't send it to myself. Sent myself a lot of crap.
Oh, this the more massacre in Greece.
Well, I'll have to figure out what it is at another time. It had something to do with. Ow! Oh, my bones hurt.
Yeah, it was division drafted out of basically secret police.
Aren't you guys sick of just being on a computer all year?
Yeah.
I mean, I know you guys are on computers all the time, but I just hate school on a computer.
Yeah, it's like it feels so stifling because it's like you stare at a screen and it feels like you're not supposed to speak at all.
You have like 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then you have all of your operations, plus, minus, times, and division. And you can only use each number once, but you can use the operation as many times as you want. So you can use plus, minus, times, and division as many times as you want. But you can only use each number once. And you have to get them to everything to equal something. I believe it's I want to say 9. It might be 7 or something like that. And if I can't remember the number, it doesn't work, right? So you have to use all of the numbers, and you can only use each number once. You have to figure out what it's supposed to be for it to be a valid game for us to play. Do you know the 9's math trick? Do you know the knowing if something's divisible by 3 trick? Do you ever wonder if any number is divisible by 3? Say 431. You don't know if 431 is divisible by 3. All you have to do is add the digits. 4 plus 3 plus 1. 4 plus 3 is 7 plus 1 equals 8. If 8 is divisible by 3, this number is divisible by 3. If not, I can tell you now 431 is divisible by 3. Well, 4 plus 3 plus 1 equals 8. And if 8 is divisible by 3, 431 is divisible by 3. If it's not, then it's not divisible by 3. You can do it with any number. 4,032. So we've got 4 plus 0 plus 3 plus 2 equals 9. And 9 is divisible by 3. So this is divisible by 3.
I think I'm getting it. So correct me if I'm wrong. So I'm guessing. So divisible by 3, right? You mean by if it goes like by down the scale 3, 6, 9, 12.
Well, you can divide it by 3 and get a whole number answer.
So if you get any of the numbers that like are adding up by 3, it's right.
So we can go 4032 divided by 3. Taking it back to long division. We go 3 goes into 4 one time. Drop to 0. 3 goes into 10 3 times. We get 9. 3 goes into 13 4 times. We get 12. And it divides evenly, right? So, and it works with absolutely any number. If you're like trying to factor something out or see how it works. If it's divisible by 3, you'll know just by adding up the digits. What other trick? 9s. Everyone should know the 9s one, right? If you look at 9 times 1 is 9.
Oh, I know.
9 times 2.
So
Oh,
I
really?
learned that like in 3rd grade.
And all the digits add up to 9?
No, there was another trick too. It's like like 9 times 7, you like count backwards from 7 and then go up by 7, right? I think that's how I remember it. 9 times 3 equals 27.
I always go, okay, if it's 3, it's going to start with 2. If it's 4, it's going to start with 3.
The way I know it, it was like you go down one number and then go all the way up back to 9, and that's how you get your answer.
Yeah, add it to 9.
Yeah. So that's how I'm so fast.
I like math tricks.
It all goes
Yeah. Now this doesn't carry on past like the first like 10 or 12. The next one's 99. 11. I love those kind of things. The divisible by 3 one, I was in my 3rd year of college before I learned that as a math major. And someone said, hey, you know the math trick? It's divisible. You add up the digits. I'm like, no, never heard of that wizardry, that witchcraft you're showing me.
It's sounds like such a simple trick. Because all you do is addition.
Yeah.
You know, that's pretty easy.
Well, you still have to divide, but you're dividing by a much smaller number.
I mean, yeah, you have to divide by you know.
Oh shoot! I never stopped my recording. Hopefully, I could trim it down. I tried to trim. I had a